Hello, everybody. Today we are going to be learning about stepping up to balancing equations and types of reactions. This is our very first time we're looking at balancing equations, so like it says, we're stepping up to it. Okay, I'm sure a few of you rolled your eyes already, which is perfect. Let's get going for today. First and foremost, things that we are wanting to look at today is we want to be able to determine if and when a chemical or physical change has occurred, and also prove that matter is conserved in any reaction. So if we're going to have a chemical reaction, there's going to be a physical change that has occurred. We also need to be able to show that matter is conserved in any reaction. So when we're balancing the equations, it's because we need to show that matter is not created or destroyed. Best example is, remember back to our chemical reactions lab when we had there was that baggie and we put some powder in, which was baking soda. There was kind of those little ball type things, which was the calcium chloride. And then we had a little cup with some red stuff, the phenol red. And when we kind of squeezed out as much air as we could and closed that bag up, we then dumped the red into the powder and the little ball things, and we started mixing it. And as we mixed it, we started to get really warm, and we also started to turn yellow. So those are two signs of a chemical change occurring. It also started to expand. That's where conservation of matter comes into play, because a lot of times those gases escape into the surroundings, so we never see where those go. With what we're learning about today, we're going to show where those ones went. We're going to have a lab coming up, which it's going to look at, and you're actually going to get to see how this actually works out. It's going to be in the Hoffman lab, and we're going to see how water can be separated into its two gases, and you're going to see this in real life, which is pretty cool. So that's coming up. As we get going today, we do have a few things I just kind of wanted to quick little bit review. We've learned about them like in our textbook. We've talked about them a little bit here and there, but let's have a little bit of a tiny review. So we're going to use this equation as our little helper. So when we look at this, there's a few little parts and pieces we want to know. What we start with, this is what we have as these are our reactants. And these are the things that are going to react. Then we have our arrow, and our arrow is just kind of there as a placeholder, and it says it's yielding what? If you've ever heard of like crops yielding so many bushels of, say, corn, so it's a yield. And then we have on the other side is our products, because that is what has been produced. So we have our reactants and products. Whatever we start with, we must end with, or whatever we end with, we must have had that same amount to begin with, because conservation of matter says that we cannot create or destroy any matter. Now, there's two other things we want to have, and if you wanted to put this somewhere on your paper, it would probably be a really good thing to add here. We have some other things. We have this little number, and then remember, if there's not a number here, we have like a ghost number, and it's this big number out front. This little one, remember, is called a subscript, and this big guy is a coefficient. Now, these are going to be important today, because when we get talking about these, we cannot change the subscript. If we change the subscript, we're changing what type of compound or substance this is. Now, our coefficients, these are the numbers we can change. You might already be starting to look at this and you're like, wait, I have 2 hydrogens here, 2 here, but I've got 2 oxygens and 1. If you're saying conservation of matter, this doesn't work. And you would be correct. So we can change the coefficients, but we cannot change the subscripts. We cannot put a number in next to here. We can't just go H2O2, because that takes this from being water to hydrogen peroxide. You can drink water. Drinking hydrogen peroxide, I suppose you could drink it once, but it's probably not going to go so well. So we cannot change those subscripts. Another thing, just kind of a little quick review, is when I was saying how many of those hydrogen or oxygen atoms, you might have been like, oh, Miss Moronic, I don't remember. Counting atoms was a little while ago. So let's do just a little quick review of counting atoms. So we have H2, we have O2, and we have H2O. So if we're going to count our atoms, this subscript tells me I have 2 hydrogen atoms. My subscript of 2 tells me I have 2 oxygen atoms. And then this is telling me I've got a subscript of 2 next to my hydrogen, so I have 2 hydrogen. And there's not a number next to the O, so it's 1 oxygen. Now, how did I know that these were 2 separate elements? Every time you see a capital letter or a new capital letter, that is a new element. If I look down here, so HGO, this is saying capital H, little g. In fact, that's mercury. And then O is oxygen. So there's 2 elements here, not 3. If I go back up to my counting here, now remember I said something about coefficients and subscripts above? So let's just put some numbers in to our examples here just to see how coefficients can change this. So let's say we're going to have a 3 as our coefficient out front. That's saying I have 3 groupings of hydrogen. So instead of 2 hydrogen, I actually have 3 times 2, so I have 6 hydrogen. Let's go slightly crazy. How about a 7? I know, you're like radical, Miss Morodic, or you're just rolling your eyes. But here, it's now saying I have 7 groups of this substance. So I have 7 times 2, so I actually have 14 oxygen now. Let's put a number out front of the water. We'll go 2 to make this a little bit nicer. So this is saying I have 2 groupings of water. So that means I need to multiply my hydrogen and my oxygen. So I actually have 4 hydrogen here, and I actually have 2 oxygen here. I'm going to set these aside now, but we're going to need to count atoms because that is going to be now our simplest part of what we're learning about today. I'll set these aside so we can come back to them if we need. So that's our little review. Let's jump into our different types of equations. The first type that we have is called a synthesis reaction. This looks like we're putting parts together. When we look at it, a little helper is we're going to have a plus sign on only the left side. A synthesis reaction is going to look like if you have like flour, sugar, egg, ingredients, and you get cookies at the end. Okay, well, that's not quite exactly what we've got here, but that's a way to think about it. Because you're adding all these things and you're getting one product at the end. Or if you're like, okay, I get all these things and then I get one cake at the end. But you're adding all these things together and getting one thing at the end. Also, if you've ever heard of like a synthesizer, it's a type of like piano where one key has like the drum beat, another one might have like a guitar, another one might have a saxophone. And when you put those all together, you get a song. You get one song at the end. So you get all those things added up and then you get one thing at the end. So if we see a synthesis reaction, it'll look like this, that we only have a plus sign on one side. There's other ones coming up, so you can see that there's a plus sign on the other side, but those are your little helpers. In fact, today what we're doing is making ourselves a cheat sheet. You can even keep this when you go up to the high school because balancing equations, this is our first look at it. We're going to need to know just a little bit about it for our classes, but when you get into high school and get into chemistry, if you decide to take science into college, you're going to be doing a ton more of balancing equations. So our synthesis reaction, we have one here. We have 2 things becoming one. So our steps. First thing we need to do is look for our odd man out and make it an even number using coefficients. So if I look here, what that means is I have 2 hydrogen atoms. I have 2 oxygen atoms. Over here, I have 2 hydrogen, but only 1 oxygen. That's my odd man out. So I'm just going to right away just double that because then everything's even. Can't really balance things out as easily when they're in odd numbers, but evens make it a little easier. So now that everything's even numbers over here, I now need to go back and forth. Reminder, I could not change the subscript. I cannot put a 2 after this 0. That changes it from water to hydrogen peroxide. That's not allowed. I can change coefficients. That's how this works. So now I'm going to multiply the entire molecule by this coefficient. So 2 times 2 hydrogen, that means I have 4 hydrogen. 2 times 1 oxygen, I have 2 oxygen. If I look then, where to next? Are atoms on each side balanced? I have 4 hydrogen, 2 hydrogen. What number am I going to put there? If you said 2, you're correct. So now I have 4 hydrogens, 4 hydrogens, 2 oxygens. When I multiply that, I have 2 oxygens. I'm good to go. I just need to get them so that all the elements on each side are equal. Now our next one. This is a decomposition type of reaction. And this is like we're taking it apart. It's breaking apart. We have a plus sign on only the right side this time. And a way to think about this is you throw a banana peel into a compost pile, and then you get minerals and dirt out of it. So you're getting multiple things as it decomposes. So we're going to do the exact same thing again here. So first thing, look for the odd man out and make it an even number using coefficients again. Remember, not subscripts. So if I look here, I've got 1 mercury, 1 mercury. I said to look for the odd man out. There's my odd man out. So we're going to double it over here with our coefficient of 2, because then it makes it, I have 2 mercury. And then I'm going to put a 2 in front of this mercury because I want to have 2 on each side. Now when I added this 2 as a coefficient, it also made it so I have 2 oxygen. Do I now have 2 oxygen over here? The answer is yes. Now if you're like, Miss Moradic, I'm just not getting. What this was looking like is we had like mercury bonded to an oxygen yields a mercury plus one of these, an oxygen that has like 2 together. This all doesn't work out. So when we added this coefficient, it made it so we have a second mercury and oxygen set, and we have another mercury set over here. 1, 2, 1, 2, 1, 2, 1, 2. Are both my sides equal? Yes, they are. Oh, wait. On the back, this is our last one, and this one is a combustion reaction. This is burning a fuel. There's a plus sign on both sides of the reaction. So in a combustion reaction, this is where we have fires, or we have burning of materials, or we're getting energy out of it. We could even have maybe a small explosion because of a combustion reaction. So a combustion reaction uses a fuel, which is going to be wood, paper, oil, gasoline, propane, methane, etc., and it burns with oxygen. Fuels are sometimes called hydrocarbons as they're made of carbon and hydrogen together. Combustion reactions always produce these 2 things: water and carbon dioxide. Remember, as our little review at the beginning of this, reactants are at the front, products are at the end, because reactants, this is where the reaction is taking place, and this is what we get at the end because it's what's been produced. I just said produces H2O and carbon dioxide. So if we see water and carbon dioxide on the back half of the equation, it is a combustion reaction. Okay, so first thing we're going to do, the steps look a lot the same. Something that usually is helpful is to just double our water on the product side. Why? Remember, we're looking for the odd man out. I have 2 oxygen on this side. I only have 1 over here. So just doubling that is going to help take care of that. We might have to still change this a few times then. Then we're going to look at either the carbon or hydrogen on the reactant side, and you get to choose who do you want to go after. We either need to attack the carbon or we need to attack the hydrogen. You can choose either, but we need to go back and forth until we have these balanced on each side. Since I have no one here to choose because my classroom is empty, except for my adorable little stuffed animals that are in front of my desk, I'm going to choose the carbon. We have 3 carbon ones here. So we have 3 carbon atoms. I need to get this, so I have 3 carbon atoms over here. How can I do that? I can only change the coefficients, so I'm going to put a 3 out front. Now, let's attack the hydrogen. And if you're like, wait, Miss Moradic, why not look at the oxygen here? We're going to leave the oxygen for our very last step. Because once we've changed everything over here, and if we've made sure that this stays even, and this one already has 2 oxygens, so the oxygens are going to stay an even number no matter what, then we can just break it divided by 2. It'll be good. So we'll just leave this guy alone. So we attack either the carbon or hydrogen. We just attacked the carbon. Now, time to attack the hydrogen. So I actually need 8 hydrogen. Right now I only have 4, so I'm just going to get rid of this. If you have a pencil, you could just erase it. How can I get 8 when I've got a 2 here? So if I have, because remember, this is like saying I have C, 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 H, 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 H. And then over here, I've just made it so I had a C. Oops, we'll just make that an O. And then I have, right? So by adding a 3 here, I did. How can I make it so I have 8 total hydrogen over here if every set has to have at least 2? Well, 8 divided by 2 will give me 4. So that means I've got, I'm running out of space. 1, 2, 3, 4, 5, 6, 7, 8. Fantastic. My hydrogens, or my carbons are happy on each side. My hydrogens are happy on each side. They got moved around because there was a chemical change. That's fine. Now we need to figure out, we need to come back to our oxygen because that one is not happy on both sides. So how many do we have on this side? And then we'll just divide by 2 over here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How else could have I gotten that? 3 times my 2 here gives me 6. 4 times 1 gives me 4 of them, which gives me 10. So how can I make this oxygen? So I've got 10. I'd need to put a coefficient of a 5. And then I have, is everything happy if this is my dividing spot? 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Everything here is happy. Now sometimes with combustion reactions, if mine start to look a little messy, I will rewrite them just so it's a little easier to see. So C3H8 plus 5O2 yields 3CO2 plus, I didn't leave enough room, 4H2O. We will come back to this. We will have a few more practices with some counting atoms. Your science teacher probably has a few different websites you can go to practice this. Also, some videos, little helper videos are also made available by your science teacher. Check those out. These aren't going away anytime soon, and you're definitely going to need to know these. Hopefully, you're like, this isn't so bad, because honestly, it's like a little puzzle to solve. Have a great day, guys. Thanks for joining.